Ancient dream meets modern science for millennia. Humanity has chased an impossible dream: to live forever, or at least to extend our healthy years far beyond what nature intended. From ancient myths of elixirs and fountains of youth to philosophical debates on immortality, the desire to escape the clutches of time has always captivated us. Today, we re-diving into one of the most profound questions of our time. Can we truly stop aging? And what are the revolutionary new treatments that promise to redefine human longevity? Get ready, because the secrets of a longer, healthier life might just be within our grasp. It's an essential coenzyme found in every cell of your body, playing a critical role in over 500 metabolic reactions, including energy production, DNA repair, and gene expression. These compounds can be converted into NAD+ in the body, boosting its levels. Pioneering researchers, most notably Dr. David Sinclair from Harvard, have shown incredible results in animal studies. Mice given NMN saw improvements in their muscle endurance, metabolism, and even had their biological age reversed in some tissues. While human trials are ongoing and still relatively small, early results are promising, suggesting potential benefits for metabolic health, cardiovascular function, and even cognitive sharpness. The possibilities seem limitless. With synthetic biology, the traditional boundaries between disciplines blur, paving the way for groundbreaking innovations. By harnessing the power of biology, we can tackle some of the world's most pressing challenges. This includes developing sustainable energy solutions, producing life-saving pharmaceuticals, and creating eco-friendly materials. The future of synthetic biology is incredibly promising. It's like giving your body's internal engines a fresh tank of high-octane fuel. One of the most significant contributions of synthetic biology is the development of personalized medicine. The ability to alter the genetic makeup of organisms raises profound questions about the very definition of life and the boundaries of scientific intervention. Navigating these uncharted waters will require careful thought and consideration to ensure that our actions today do not have unintended consequences for generations to come. By understanding the unique genetic makeup of each individual, we can tailor treatments that are more effective and less prone to side effects. Only through thoughtful consideration, robust ethical frameworks, and a commitment to transparency can we harness these incredible tools for the betterment of humanity while safeguarding the principles that define our shared future. As science marches forward, we must also consider the ethical, social, and economic implications of these groundbreaking discoveries. But what's clear is that science is making unprecedented strides. Many of these treatments are in early clinical trials, showing immense promise, but still requiring rigorous testing for safety and long-term efficacy. They are not yet widely available cures, nor are they without potential risks. This approach holds the key to unlocking new therapies for a wide range of diseases, from cancer to rare genetic disorders. Imagine living to 100 or 120, not frail and sick, but vibrant and active. That's the immediate, achievable goal. As we delve deeper into understanding our own DNA, it's crucial to ensure that sensitive genetic information is protected from misuse, and that individuals are not discriminated against based on their genetic makeup. Striking the right balance between scientific progress and ethical considerations will be a defining challenge of our time. It's imperative that we engage in open and transparent discussions involving scientists, ethicists, policymakers, and the public to to shape the future of these technologies in a responsible and inclusive manner. But it's important to remember, while exciting, this is still an active area of research, not a magic pill. Instead of relying on chemical processes, synthetic biology enables us to harness the power of cells to produce valuable compounds, such as biofuels, antibiotics, and even biodegradable plastics. This shift towards biological manufacturing is not only more sustainable, but also offers a greener alternative to conventional methods. The problem? NAD+ levels naturally decline as we age. As we continue to explore this field, we are sure to uncover even more groundbreaking applications that could transform our world in unimaginable ways. As we stand on the cusp of these incredible advancements, one question arises: are we truly ready for what lies ahead? Synthetic biology and gene editing offer tremendous potential, but they also present ethical dilemmas that we must confront head-on. This damage accumulates over time, breaking down the very essence of your cells and contributing to the aging process. What if we could turn back the clock on this damage? Enter gene editing technologies like CRISPR-Cas9, which allow scientists to precisely target and correct these age-related mutations. This decline is linked to many age-related issues, from metabolic dysfunction to neurodegeneration. Now, while this sounds like science fiction, it's actually becoming a reality. For instance, researchers at the Salk Institute, led by Professor Juan Carlos Ispizua Belmonte, have found a way to use CRISPR to restore youthful epigenetic marks to old cells, making them behave biologically younger. This could potentially combat many aspects of aging by tackling the source of the problem. However, it's crucial to note that gene editing, while immensely powerful, is a double-edged sword. It raises ethical questions about altering the very building blocks of life. We must tread carefully, ensuring that these powerful tools are used responsibly and ethically. But what if this age-old dream isn't just a fantasy anymore? Imagine a scenario where we could potentially rewrite the code of life itself. Enter the world of synthetic biology. Synthetic biology is like an advanced toolkit that allows us to not only understand, but manipulate the very essence of life. This field merges engineering principles with biology, enabling us to design and create new biological systems that never existed before. It's not just about wrinkles and gray hair. At its core, aging is a complex biological process characterized by the gradual decline of cellular and organ function. In our mitochondria, the powerhouses of our cells become less efficient. Crucially, some cells enter a state called cellular senescence, where they stop dividing but don't die. These are often called zombie cells because they hang around, secreting inflammatory molecules that harm neighboring healthy cells and contribute to age-related diseases. Understanding these processes is the first step towards intervening. That's exactly what cutting-edge research is doing right now. Scientists have identified several hallmarks of aging, fundamental mechanisms that go wrong over time. What if, with the relentless march of scientific discovery, the answer to stopping aging is closer than we ever imagined? Welcome to Sciencepect, where we explore the cutting edge of science, technology, and space. Before we talk about stopping aging, we need to understand what aging actually is. Think about it. Our cells accumulate DNA damage, or telomeres, the protective caps on our chromosomes, shorten. One of the most talked about molecules in longevity research is NAD+, or nicotinamide adenine dinucleotide. Enter NAD precursors, like nicotinamide riboside, and nicotinamide mononucleotide. Think about it. Your cells are constantly taking damage from UV rays, toxins, and just the normal wear and tear of living. It's like having a microscopic pair of tweezers to fix the frayed wires of our cells. As incredible as those approaches are, science is pushing even further. Think about designing cells that produce vital compounds, create entirely new organisms, or even engineer bacteria that can clean up environmental pollutants. But what does it mean for the future of humanity? Another exciting application lies in the realm of biomanufacturing. However, the potential of synthetic biology extends far beyond these examples. One of the most pressing concerns revolves around genetic privacy and discrimination. Moreover, as we unlock the secrets of gene editing and synthetic biology, we must also consider their broader implications for society. So the question remains, are we truly ready for the transformative power that synthetic biology and gene editing hold? So, can we truly stop aging? The answer today is not yet in a comprehensive, proven way. The focus is largely on extending health span, the period of life spent in good health, free from chronic age-related diseases, rather than just lifespan at any cost. The future of aging research is bright, filled with hope and the promise of a better tomorrow. If you found this video fascinating, please give it a thumbs up, share it with your friends, and most importantly, subscribe to Sciencepect for more mind-blowing science and technology content. We're unlocking the future, one breakthrough at a time. What are your thoughts on these incredible advancements? You believe we can defeat aging? Let us know in the comments below. Thanks for watching, and we'll see you in the next video.